Okay, on this one, we're taking the limit as x approaches infinity. So, first we'll try direct substitution. I'll plug in the infinity there, and anytime I'm plugging in infinity, I'm just thinking, I'm plugging in a huge number. So if I take a huge number and I raise it to the fourth power, it's still going to be big. Times it by 7, still going to be a huge number. So this will be infinity. But, x squared, infinity squared, times 2, still a huge number. So I'll have infinity plus infinity, which will just be infinity in the top. And then the same idea on the bottom. I have a huge number plus a huge number, still infinity, minus 5, still really huge. 5 is relatively small in comparison. So I have infinity over infinity, which is an indeterminate form. So that means we gotta try some tricks. Let me erase this stuff. So the trick when you have limits at infinity is, so this is what tells you this part, as x is approaching infinity, you try stuff. If you get an indeterminate form, there's a trick that you can do. So the trick as x approaches infinity or negative infinity. In the other videos, well, yeah, I'd say force factor the highest power in the denominator, and force factor the same power in the numerator. So that's what we're going to do. So it's factor out the same, factor same from numerator. Okay, so if I look at the bottom, the denominator, the highest power of x is x to the third. So I'm going to force factor out an x to the third. So let me just rewrite this part. So I have 3x cubed Is that right? Yeah, okay. So now now I'm going to force factor out a negative, sorry, not a negative, an x cubed. So if I factor out an x cubed, I'm left with just 3, and then plus 1 over x squared. The way I know this is if I distribute back in, oh, I get 3x cubed. Okay. If I distribute that back in, I get x cubed over x squared. And then, I don't know if that's a... Oh, I'm still recording. Sorry. If I distribute that back in, I get this, x cubed over x squared. Remember, you subtract the exponents when you divide. That just gives me regular x. So that's how I know I'm doing it right. That's how I know I can force factor that stuff. And then we have minus 5 over x cubed. Again, if I distribute this back in, I get negative 5, because they cancel on the bottom, like x cubed times 5 over x cubed. They cancel. That's a multiplication. And then it leaves me with negative 5, or whatever it was. Okay. So that's that. Let's see. Now I factor out the same in the top. That's what the thing was saying. Force factor the highest power from the denominator, factor same from the numerator. So I'll factor out an x cubed, and then that'll just leave you with 7x plus 2 over x, right? I think so. So now those cancel, and then I'm going to try and evaluate my limit once again. So this will be the limit as x approaches infinity. Alright, so again, when I plug in infinity, this would go to infinity. This part, this is the special case, this is like one of the fundamental limits. X approaches infinity of 1 over x, that equals 0. Because as the denominator gets super, super huge, the whole entire fraction gets really, really tiny. Okay, so this goes to 0, this goes to 0, this goes to 0, and this just stays a 3. So, what do we have? We have infinity over 3. This is no longer an indeterminate form, so we would say this limit just goes to infinity. So this limit actually goes to infinity, so that would be our answer. And that's all she wrote. Hopefully that's understandable. Goodbye.